All right, welcome back. So today we are going to solve a very, very famous problem. It's reversing a linked list. On my channel, we joke a lot about not knowing how to reverse a linked list, and I think the reason why people joke about it is because it's such a I would say it's a little bit useless. I don't think you'll ever encounter this in a real software engineering job, but they used to ask it a lot. Is to make sure you know how to use pointers and understand how to manipulate them. The thing about pointers is that you learn it at a very early stage of your college career. So, and then a lot of the times when you learn C or something like that, you start to learn linked lists, because that's usually how you linked a character. You linked a bunch of characters and which forms a string. So let's look at that. And then, let's look at the question. So very simply, reverse a linked list. All right, and so here you have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then your output would be 5, 4, 3, 2, 1. So we're gonna do it both recursively and iteratively, because I think it's worth looking at both of them just to understand how it works, how linked list works. So the first thing that I have to talk about, let's go to the iPad. The first thing that we have to talk about is what is the structure of a linked list. So linked list is actually just a bunch of nodes. And then in node, like we can see here, let's write the class. The class node is basically, here it's written list node, but I'll just write node. It's composed of two things. There is a value, which could be an integer, character, or just like a data struct, data type. And then you'll have next, which is actually a pointer to a node, right? And then how it works is, the best way to represent it is actually just a bunch of squares. So a node looks like this, right? And then here is the value, and here it's next. And a value can be like, let's put a number like 3, and then next will be actually an address. The address will be actually a hexadecimal number, but here we'll just represent it with something easier, like a dot and an arrow that points to another address, which represent to another node. 2, 1, and then we'll have like a slash to say that this is the end of the linked list, which is similar to pointing to null, which is the address 0, right? So this is basically a linked list. Now, how do you reverse it? Okay, cool. Let's look at let's look at a linked list 1, 2, 3, 4, 5. Let's draw it out. So 1, 2, 3, 4, and 5. All right, so what we want to do is we want to end up here like this. 5, 4, 3, 2, 1. Awesome. Yeah. So how do we do this? So let's do the recursive way first. I like to think of things recursively. I think it's a good exercise to have. Now, when you think recursively, imagine if a big chunk of it has already been solved for you, and then what are you going to do next to complete the equation, to complete the function? So for example, here, actually, there might be a better way of representing it. Let's just do circles 2. So I don't need to redraw it so many times, but you do understand what it means. And then this is like null. So imagine if you start at this node, because your function, basically you just take in a node, and then that's what your list is. So you have your node, and what you want to do is you want to end up like this. So imagine you call a recursive call here, and it just automatically works. So imagine if it already works, then what would it look like? It would be reversed already. So then it would become 5, 4, 3, 2, and then 2 would point to null. And then, but 1, it used to point to 2, it still points to 2, because you didn't change anything here. So 1 will point to 2. Okay, so what is there left to do? You want it to look like this, right? You want it to look like this linked list. So the only thing we need is we need the 1. Let's put the purple. We want the 1 to go all the way here, and then this will point to x. So what do we need to change? First, we need to change this, because currently it points to null. And then we need to change this arrow. Instead of pointing to 2, it should go to null. So what do we need to change? First, we need to change the 2's next. So currently 2's next goes to null. So what we can do is we could access the 2 and then change it to O of 1. Sorry, not O of 1, to point to the node number 1. And how can we access the 2? It's actually pretty easy because we'll use the 1. So we can kind of think of it this way. This is the head, because originally that's what we were given. The head dot next will be 2, right? Because this is basically head dot next. This is head. And then we want to change this arrow. And what is this arrow? It's another next. So we want head dot next to be equal to me, which is head, right? And then we want the one arrow, the head dot next, to point to null. And then that's pretty much it. And then now you have the linked list, and now you have to return 5, which you will get from the recursion. All right. So before we do the iterative one, I just want to code it up to show you. All right. So first, you need a few base cases. What would happen if the linked list is a single linked list, or if there's nothing? Well, if it's nothing, then you just return it. You just return the original linked list. So if head is none, or if head.next is none, okay, then you just return the head. And then let's look back at the iPad. What we wanted to do is we want to call the recursion first. So the new node, let's just call this the new node, equals reversed list of head.next, because we want to reverse everything that's in front of us. And then assuming that it's all good, what we want to do is we want to change, let's see, head.next equals head. And then we also wrote head.next equals null, which is none here. And then we want to return p. Let's see if that works. Oops, syntax error. Or head is none. Let's try this. Reversed list. Oops, so. All right, cool. So yeah, it works perfectly. Output is this, expected is that. Let's submit it to see if it works. All right, cool. So yeah, as you can see, we submitted the code and it works. So that's how you do it iteratively. So think about it a little bit. What is the time complexity of this? In here, it would be O of n, because what you do is you have to call reverse linked list at every single node, and then basically you just travel through the whole linked list once, which is O of n. And then space complexity would be also O of n, but that is because we have the call stack. And in the call stack, we call reverse list like as many times as there are nodes. So that means, and there are n nodes, so that means the call stack would be O of n. All right, so I'm gonna do my laundry real quick and then we'll do the iterative version. So now we're going to do iteratively now. Let me erase this. Okay, so once again, we're gonna redraw the list. 5 and then null. Okay, so then this time what we want to do is we want to do it one by one. We're going to go through the list and we're going to keep reversing it, and then we're going to return the tail of it. Is it called the tail? Yeah, the tail of it. So what you want to do is think of your pointers. We're going to need 3 pointers. We're going to need a previous pointer, a current pointer, and maybe sometimes a temporary pointer. So first, what we want to do, imagine if you want to reverse it. You want to have a pointer here, which is like the previous one, and you also want the current one. And what you want is also like a temporary one, temporary pointing to these. And then it's very simple. Like intuitively, what you want to do is you just want to grab this one, point it to here instead, and then take off this. Sorry, first you take this off, this from the previously, and then for the current one, you want to point to the previous one instead of the next one, and then you remove that, and then that's it. So you do that for every node. So if you shift these guys this way, and then next, what you'll have is you'll have the same thing, but this time this one is the previous guy, this one is the current guy, and this guy is the temp guy. And then you do the same thing, you just point it this way, right? And then you shift it again. You don't need this guy anymore. The current becomes previous, and then temp becomes current, and then this is a new temp, and then you reverse it again until you're done, right? So we could actually look at this, exactly what we did, and write it in terms of our solution. It's actually a one-to-one mapping, like you said, like I said. So let's just do it. So first, like I said, we need a previous. So previous, it starts with null because the first node is the first one, and we want it to point to null. So the current equals the head, and then while the current is not null, the reason why we do that is because we want to go all the way to the end of the list, and once it goes out of the list, meaning it's the end of the list, then we stop. So like I said before, we want temp to be the one that is further away than everyone. Like if we look at our thing here, actually let's put the screen on and my iPad at the same time. Cool. So prev is null, current is 1 right now, right? And then what we want to do is we want a loop where temp would be the next of null. So we're going to write that here. Temp equals current.next. Excellent. And then what do we want to do? We want to change this arrow to point to previous, right? So we want to do that and then take off this arrow. So how do we do that? Current next is previous, okay? Current.next equals previous. And then what do we want? We want to shift this. So we want previous to be here. And then, so previous equals current. And then we want current to be the next one. So current will be here. So we'll be taking what temp is. So current equals temp, right? So then this becomes nothing, and then temp becomes nothing again, and we repeat the process. And then at the end, once we go to the end, this will be previous, this will be current, and then that is the end of the state. So return previous. So yeah, so now you have arrows going this way, and then you'll return this guy as the head. So let's run it, see if it works. All right, it works, and now if we submit it, and that works too. So yeah, that's pretty much for reversing a linked list. And yeah, congratulations, you can reverse a linked list now. I know we joke around a lot about not being able to reverse a linked list, but you should be able to reverse a linked list because that's pretty much a fundamental question that you should be able to answer. All right, see you next time.